Right now, tied up with the last module, we're now going to look at the first mandatory experiment in organic chemistry, the preparation of ethene. Now, it's experiment number 21 on your mandatory list. You have a full list of all the experiments on your course. There's 30 of them there. This is 21. The preparation and properties of ethene. It's very popular. It's very easy marks, and you want to really just make sure you're familiar with this. Now, you should all have that page in front of you right now. And I have outlined the apparatus for it there. You'll be filling in the blanks of A, B and C as we go through that, okay? So if you haven't, please pause the video, go away and get it, please, okay? You need that immediately for your work, and go and get that now, please, and you'll be fine. All right? Now, the preparation of ethene then, let me tell you, I'm going to show you some of the apparatus and give you a sense of what you'll be doing there with this. I better just use the equation first. You basically take a colourless liquid, ethanol, it's an alcohol. Ethanol, a colourless liquid, okay? And you basically vaporize it or turn it into a gas. And in the presence of a catalyst, it will produce ethene for you. Now, the reaction is very simple, really. C2H5OH is ethanol. Now, are you okay with that? Eth means, effectively, eth means two carbons, and it's ethanol, and alcohol has OH in it. Now, take my word for that for the moment. That's the colourless liquid ethanol, okay? And basically what happens here is, when you heat that in the presence of a catalyst, you're going to get C2H4 plus H2O. You're going to eliminate water from it. Now, it's actually called an elimination reaction. Now, that's not of any concern to you at the moment, other than that reaction takes place when you heat it. At high temperature, you have to heat it, okay? And when you do that, you're going to get a reaction. Now, I have to tell you that they need aluminium oxide. It's a white powder. That's the catalyst, and you need to heat it. Most catalysts will not work at a room temperature. You have to drop the temperature, okay? So you have to raise the temperature. When you drop the temperature, it won't work. You have to raise the temperature to get it to work. So you heat this. This is a white powder. Let me show them to you then. This is the alcohol. It's a colourless liquid ethanol. Now that's 90%, so be careful, please, as regards to what you're using. And this is the white powder. This is just a sample of aluminium oxide, okay? And you put it into a boiling tube, as shown in the apparatus there. There is the apparatus here. You put them into that. Now, the sequence in which you do the things is very important. Now, even though I'm not doing it for you here, I need you to know as well what I'm doing. Let me just show you a few things. I have rubber gloves here. At this particular time in our careers, rubber gloves have a second meaning, haven't they? But I have to use a protective glove here. You're not supposed to handle some of these chemicals. I'm mentioning that to you, right? For a few reasons. Basically, you take a boiling tube. That's not a test tube now, a boiling tube. It's a large test tube, okay? And you put some alcohol into it. You pour the alcohol into it to about 2 centimeters deep. You literally pour the alcohol in there 2 centimeters deep. And then what you do is, you take some of this fellow, which is glass wool. Glass wool, okay? And you notice the way in which I'm handling it. That's what the rubber gloves are for. It's fiberglass. And you put it in here, and using a glass rod, you push it down. I'm going to say that again. Put the alcohol into the tube, put some glass wool in here, and stuff it with the glass wool. Now, the glass wool serves two functions. Number one, it will dry the inside of the glass tube as you push it down. And number two, it'll soak up all the alcohol, because when you put it in here, you're going to have to hold it up like that. Are you clear on that? That's what you're going to do with that. So you're going to be holding it up in the horizontal, and that's very important that you do that. So you put the alcohol in first, and then you put the glass wool in. Now, will you be careful? It's glass wool. Don't say cotton wool. I could tell you stories about that now, but cotton wool is flammable. Would be dangerous. You use glass wool. You push it down, okay, until it soaks up all the alcohol, right? And then you're ready to set up the apparatus as shown in the diagram. Now, I have one set up here already. Let me just show you. I have it just shown like that for you. And but there's your glass wool. The alcohol will be soaked in that, and you basically have a lead tube like that. And you mount it on a retort stand, just like I'm doing here now. Okay, now very important then, as well as that, is that you take a spatula. I don't know, do I have one? I think I do. Take a spatula to put the white powder, just a spatula to put the white powder into that. Take your white powder now, and you put it into the neck of the tube here. You put the white powder in here. Now, not down there, out here. Okay, out here, the white powder in there, that's the aluminium oxide, that's the catalyst. And then you put on the delivery tube onto the end of it. That's the delivery tube going on. And so when you start to heat this in a moment, your gas is going to come out here and it is collected over water. Okay, now this is called a beehive, and that's the collecting tube full of water. It was full originally with water, and this is water as well. So as the gas comes out here, it bubbles up here and pushes the liquid down. In other words, the gas is not soluble in water, so we can collect it over water. Okay, so and when that's full, you take it away and put in another tube full of water, and you collect several test tubes of water. There, you collect these test tubes of water to test them later on, and that's effectively what you're doing. Now, folks, you only heat the catalyst. You never heat the wool. If you heat the wool, what will happen is the alcohol will vaporize instantly and nothing, you'll get no product. You'll get no product whatsoever. So you always heat the catalyst, because catalysts only work at high temperature. So you gently heat that with your Bunsen, and gradually the residual heat will cause the alcohol to vaporize. The vapor will float over the catalyst where that reaction will take place. And the bubbles of ethene will come out here, and you collect several tubes of them. Now, you must be very careful in doing some of this, and they'll ask you all about the cautions and the precautions that go with that I'm going to mention to you in a moment, but we need first of all just to know what's happening. Now, folks, I have to say something to you. That particular equation, yes, there is an expectation you could reproduce it in the exam, because it is mandatory. There's an expectation you'd reproduce that in the exam. Okay, now please, whatever you have to do that, will you distinguish between equations that you can make up or you might get out and ones that you have to know. Write a balanced equation for the reaction that took place, is what they'd say. Okay, and they'd have described the preparation of ethene and someone ask you various questions about it. Okay, that's very important. So into your notes now, you have to label the parts A, B and C. A is glass wool soaked in ethanol. That's into your notes now, there's a space there for A. Okay, B is a little heap of solid there, and that is aluminium oxide powder. Aluminium oxide powder. And C is the product gas, that's ethene gas being collected over water. Fill them in, please, in the gaps in the notes. It's very important that you have them. Okay, and I'm stressing again to you now, there is an expectation that you could write that full equation. Okay, aluminium oxide goes in last. When you've it mounted like that and the alcohol is already in here, with a spatula, put a few spoons of it in there, okay? And it would be normal to push the tube back as far as you can, because you will need to heat the powder. You only heat the powder. And that's very important that you see where the heat arrow is. It's immediately under the aluminium oxide. Okay, and that's effectively what you do to prepare the gas. Now, you must be careful. They'll ask you what precautions you take in carrying out this experiment. So listen to me now, I'll go through them with you. Whenever you're heating, you always heat gently. You don't just put the Bunsen under it and go for a stroll. Okay, you play the Bunsen on it gradually and you watch what's happening here. Now, when you start heating this container, what's going to happen initially is the catalyst will be cold. And it doesn't work at low temperatures, so you'll get no reaction taking place initially. So the bubbles coming out here at the beginning are air. And you always dispose of the first few test tubes. And you just make a case there. You just say, I would dispose of the first few test tubes, which is mainly air. And then you start collecting the bubbles of gas, and you'll find as the temperature of the catalyst increases, then of course what's going to happen, as the temperature increases, you're going to find that you'll get that, that you'll get your product being produced, and that's fine, because it's at high temperature it happens, and I've mentioned that there to you, that you have to have heat for that to happen, and that's very important. Now, mention the glass wool, please, and mention that you handle it with gloves, okay? Now, please, this all sounds lovely. Most of us in the lab won't do that. I understand that. You saw me handling it a moment ago. But you have to create a sense of care and safety. You're not supposed to handle the glass wool, so can I suggest to you that you mention rubber gloves when handling that? And please, the more bits of apparatus you name, the more marks you'll get. You push the glass wool into the tube using a glass rod. Push it down into it, not with your finger, with a glass rod, okay? You put the powder, you mount it on the apparatus as shown, and with the rubber stopper removed, using a spatula, put some of the white powder into the mouth of the tube. Now, what some people do in this instance is they put the tube like that, because they're going to be heating it here, and that's very good. That's okay, right? That you heat it here, and that like the heat will eventually cause the alcohol to vaporize, and the vapor passes over the powder and it converts to ethene, and you collect various ones of ethene, and that's very important that you can do that, okay? That's good. Now, that's the production of it, and there's not much more needed than that, except you must be very clear, and you must be able to write that, okay? So now, can I warn you about something, please, in the preparation, that one other thing here. When you stop heating this, there's a vacuum in there, because you're after expelling all the air out of it. And what happens when you stop heating? The vacuum, of course, has to be filled by something. So what will it be filled by? It will be filled by cold water from the trough. It will suck the water up here into this. And what will that do? The cold water will be hitting glass, which is very hot, so the glass is going to crack. And the gas inside is quite flammable, so that will be dangerous. Now, that process is known as suck back. And will you be careful with it, please? Avoid, that's what we say, avoid suck back. Okay, and that, I'll tell you how you do that in a moment, but basically, first of all, do you know what it is? No problem while you're heating, because while you're heating, you're producing gas, and the gas is being pushed out of the pipe. It's been pushed out, but just when you stop producing it, obviously the water from here will be sucked up the tube into the vacuum. The cold water hits the hot glass and it will crack. Very dangerous. You could get the gas to catch fire, and that would be all sorts of issues for you, so it'd be dangerous. You wear eye protection, by the way, when you're doing this. Okay, now please, sometimes I would say you're exaggerating the protection you take, but you need to take care at all times, okay? That you would have eye protection, that you'd avoid suckback, okay? And that you heat gently, so you get a steady supply of gas, not a sudden rush of it, okay? When you're about to finish the experiment and you've enough tubes collected, what you must do then is you're going to remove the heating, of course, but how will you prevent suckback? Some people say raise it up higher. That won't solve it. It'll still suck it up higher. There's no problem. Some people, they take the tube out of the water. It's okay. It's okay. The best one is to allow air back into this tube. Undo the stopper. Let air into it for a moment, and you've no vacuum. Let air into it. Just undo the stopper, let air in, and put it back again, and you'll prevent suckback. Now, you need to mention suckback as a precaution, and you need to mention how you prevent it. All very important as you go through this, because there's all sorts of issues arising, and we have to be clear on that. So you've now got your gas prepared. And lastly, now what you have to do is you're expected to carry out 2 tests on the test tubes of gas. Now, so if you can imagine now in your test tube rack, you have a number of test tubes here with rubber stoppers on them, okay? And inside them you have your gas. You have collected 3 tubes of gas, and you must do tests on them. So what tests do you do? The first thing you do, of course, is you're expected to light one of the gases to see how it burns, and that's very important, okay? It burns, okay? So you take one of the tubes, take a lighted taper, okay? Lift the stopper from it and hold it over it, and you observe the flame you get. Now, I will come back on this in the next video, because in the next video we'll be preparing ethine, and we'll be comparing the 2 of them. And at that stage, I'll fill in the table that's in your notes in due course, all right? I'll fill in that table in due course, right? But effectively, I mean, I've no problem with you filling it in now, but that table there, you know, it's the one in your notes, right? The left-hand side is ethene, and the right-hand side is ethine. So there's an expectation that you would be filling that in, okay? And we can do that in due course, right? Now, you have to show, first of all, that ethene is unsaturated. And to do that, you react it with bromine. Now, we've met this already in a previous video where we were pouring chlorine into the bromine. Bromine is yellow or brown in colour. Yellow, I'll say, if it's diluted, it'll be yellow. If it's concentrated, it'll be brown. It's yellow, okay? It's a yellow colour. And basically what's going to happen is, if you put some of that solution into a test tube of that, you'll have to tell me what happens. That's the other test they want. Now, let's start with the combustion first. You burn it, and it burns. They might ask you to write an equation for the combustion. That wouldn't be unreasonable, okay? C2H4, here we go again, plus O2 goes to carbon dioxide and water. No bother to you? And you balance that, okay? Okay, that's fine, you balance that. 2 there, you want a 2 there. Okay, the hydrogen's next, 2 there, a 2 there, and the oxygen's last. 4 and 2 is 6, so you need a 3 in there, very good. And that's exactly what you want. There's nothing more than that. That's the combustion of it. Describe the colour of the flame. You get a clean flame. It's not smoky, in other words. You get a clean flame. Could be less bright than the second gas we'll use, okay? And there's a blue tint to it. The flame then, okay? The flame is clean. Non-smoky is what that means, no smoke, okay? It burns well, okay? Okay, and that's very important, okay? It's a clean flame, right? It's less bright, not very bright, non-smoky, I told you, and there may be a blue tint to the flame, a blue flame. The word blue goes with that, okay? That'll be okay, you'll be fine with that. There'll be no problem at all, right? And then you're asked to burn it, okay? And you're asked to describe that, okay? That's fine. Now, I have there in your notes, you mix it with bromine and KMnO4. Now, they're not looking for equations for them. They are not looking for equations. If you take a tube here and you put some bromine into it, Br2 into it, okay? You pour it in, put the stopper on and shake it. Now, let me tell you the lazy way out of this. You take the test tube of the bromine, you take off the lid, and you bubble the gas through it. I have that in your notes there. I have that in your notes. Let me show it to you. I'm showing it, bubbling it in there. That's what I'd ask you to do if you were doing it in the lab with me. But the examiner isn't too impressed with that, because not much of the gas makes contact with the solution. The best answer there is take a stoppered test tube full of the gas, lift the stopper and pour some bromine in and put the stopper back and shake it, okay? And it'll go from yellow to colourless. It'll go to colourless if you're dealing with an unsaturated compound, and you are. So it goes colourless if it's unsaturated, because this reaction will take place. You are not expected to reproduce this in the practical. Br2, okay, bromine. It will go to C2H4Br2. In other words, the bromine will be taken up. What will happen, look, is that bond will break and it'll form bromine there and bromine there, and the two hydrogens will push over a bit so they can get in. So the bromine is going to disappear. And that's a sign that you have either a double bond or a triple bond, that the molecule is unsaturated, and that's what they'd want from there, okay? Mix with bromine solution, and you'll be writing in there in the table, I'll repeat them in the next video for you. The yellow goes to colourless, proving the gas is unsaturated. The yellow goes to colourless, proving the gas is unsaturated. And then you could also mix it with potassium manganate 7. We met that already today, KMnO4. So you take another test tube, lift the lid and put in the KMnO4, that's the purple solution I was using earlier, and shake it well. And the purple should go colourless. No equation needed at all here now, just that's what should happen, right? Mix with potassium manganate 7, okay? It would be acidified, by the way, a bit of sulfuric acid in it as well, acidified, and the purple colour will disappear if it's unsaturated. So your comment there, mix with potassium manganate 7, acidified, you'll be writing in there, purple goes to colourless, proving that ethene is unsaturated. Full marks. That's all they want from you. Very good. And you're asked to write an equation, obviously, for the burning. I've told you already in the last thing there. Now, I'll come back in that table tomorrow, but it's very important. Now, let me bring your notes to a conclusion for this unit so that we have somewhere that we can work with. We have dealt with one mandatory experiment then. That's fine. We can deal with that. One mandatory experiment. And I'm going to come back now and just bring you into the third category for a moment. We'll do experiment number 22 in the next video. I'll do that in the next video with you, okay? That's 21, the one we've just done now. Immediately under that, in your notes then, alkene test, brown goes to colourless or yellow goes to colourless with bromine, will you say there, please? And they've asked you in that case then to draw the structural formula for. I'm just doing this to show you where the subject goes, okay? They gave you this name now, 2-chloro, 3-methyl butene. From your notes now, they've given you this, okay? Butene, watch butene now, please. There you go. Butene means the double bond is there. Now what you're to watch that I'm doing now is the sequence in which I do things. The minute I saw but, I wrote 4 carbons. Butene is telling me there's a double bond after the second carbon. Next now, every carbon must have 4 bonds. This needs 3, this needs 1, this needs 1, this needs 3. Are you okay? And now, there's various things substituted. 2-chloro means at the second carbon, that's number 1. At the second carbon, there's a chlorine. Very good. And 3-methyl, at the third carbon, there's a methyl, CH3. Now, that's that compound. Now, I'm pushing my luck here, I know that. I haven't done this with you, and I'm taking it that, like, eventually you'll get around to that. And cyclohexene is the other name there. It just, some of these long chains can be made into rings. Just keep that in mind. They can be made into rings, and that would come up in fuels, and that's the only reason I haven't mentioned it there, because they make good fuels, the cyclic compounds. For the moment, I'm going to move on a little bit. I'm going to leave the alkanes and have a look at the alkynes as we bring this to a conclusion, all right? That'll be very important. Now, have a look at what we have here now. I've done alkanes. I have done alkenes, EN-ES. And now I'm about to look at alkynes, K-Y-N-E-S. That's the last of the hydrocarbons. That's the last of the hydrocarbons, alkynes. And from your notes again now, this homologous series is characterized by the presence of a triple bond. The first members are ethyne, propyne, and butyne. Okay, so again, as before, eth is 2, prop is 3, and but is 4, and we're working with that, okay? And that's ultimately what you'll be after. There'll be nothing to it, all right? So we're going to work on this now for a moment, okay? Ethyne, right? And I'm going to draw them for you to give you a sense. There's ethyne, 2 carbons. There's a triple bond in them all. If it's YNE, there's a triple bond. That's ethyne. Propyne has 3 carbons with 1 triple bond. Now look, that carbon has 4 bonds, 3 and 1. That has 4 bonds. Likewise here, that carbon has 3 and 1 is 4. That carbon has 4 bonds already. Needs nothing extra, has 4 already. This has 1, it needs 3 more, very good. That's propyne. And butyne then, 1, 2, 3, 4, right? And the triple bond. I'm just checking how clear that is for you. Are you able to see that? You are. That's okay. Will you take it, please? That, look, 4 of them. And this is butyne. That needs 1 more for 4. That has 4 already. That needs 2 to get 4. And that needs 3. And don't forget you put in your H's last. Now, that's very important. Like, people start putting in the H's, they go along. No, no, no. Get the number of carbons right first. Put in the functional part of it next then. Count your number of carbons. Every carbon must have 4 bonds. Okay? And lastly, put in the H's. Don't forget now, you get nothing for that in the exam. That's only a skeleton. In an exam, you have to write in the H's. Let me do it once. You have to put in all the H's. Very good. And so what's that? That's C4H6. And I should be telling you, of course, up there at the top, the general formula for alkynes is CnH2n minus 2. That was CnH2n, and that was CnH2n plus 2. CnH2n minus 2. Are you okay with that? CnH2n minus 2 is what you have there for the alkynes. Okay, so Cn. N is 4, 2 4s are 8, minus 2 is 6, very good. That one is C3H4. Cn, H2n will be 6, minus 2 is 4. And that one is C2H2, which is correct, okay? Just keep that in mind. That's the general formula at the top there, and it's very important that you're able to deal with them, okay? The Cn, H2n minus 2. Right, and there's a triple bond in all of them. And I've drawn all 3 for you there and that. You could refer to that one as but1-ine. In other words, that the triple bond is after the first carbon. Could you draw but2-ine? But-2-ine. Same rules now. This is not difficult at all. But is 4. 1, 2, 3, 4. But2-ine. There's a triple bond after the second carbon. And now make sure they all have 4 bonds. This needs 3 more. This needs nothing more, has 4 already. That needs nothing more, 4 already. And that needs 3. And don't forget to put in your H's, very good. Okay? And they tend to be isomers of each other, but everything is in the name. I have made this pronouncement to you before. When you can read chemistry, you're very good at chemistry. And I would suggest that to you now, that like the name is given to you, can you read the information? 4 carbons, there's a triple bond in it, it's after the second carbon, and then every carbon must have 4 bonds. You work it out, don't forget to put in the H's, I keep telling you that because that's most important, right? And that's but1-ine, and that's what you'll be dealing with that, right? Now, I think more than anything else then we just have to be aware that, you know, the chemical properties of the alkynes, they're unsaturated, so they will undergo addition reactions as well to start breaking up there, okay? The chemical reactions of the alkynes. Ethyne is representative of the series, and you're expected, ethyne is the one that's representative, so we'll take that one only for the moment. That's ethyne there, okay? That's ethyne. Is representative of the series, and you're asked to write an equation for the combustion of ethyne. Easy. C2H2 plus O2 will always give you, for all organic compounds, carbon dioxide and water, and balance that by inspection. Are you all right that you can do that? Start with the carbons, 2 there. Hydrogens are next, they're balanced already, and oxygens are last. 2 2s are 4 and 1 is 5. Do you know what you're going to do there? That's 2.5 in there. That's okay. You can raise a half, that's fine. 2 2.5 is 5, 4 and 1 is 5 is right, okay? Remember, that's 2.5 moles, so the half is okay there. There's no problem with that. All right, that's fine. Now, addition reaction then, if it undergoes addition reaction, it happens in 2 stages. The triple bond will break first, and that's the way they're dealing with it. Do you see that? I have it in your notes. Should I write it again for you? Maybe that will be helpful. A H there and a H there. Yeah, you have a triple bond there, be careful. Now please folks, I don't always practice what I preach. Your writing needs to be good here. There'll be no one allowed for that, okay? And you're adding in. I have XY in your notes. Let me put just Cl2 in there for the fun of it. And what that will do now straight away is it's going to break that bond. So what you're going to get is you're going to get a carbon double bond. You're going to get a H here, a H here, a Cl there, and a Cl there. Do you see what's happened? You split one of those bonds open, and a Cl went in one side and a Cl went in the other. And now if you reacted with more HX, that's what would happen, Cl2. You'd now break the double bond into a single bond. You'd have a H, a Cl, a H, and a Cl, and the last 2 Cls again would be in there. Okay, and that's what you get. Now there's more work in that. In your defense now, I'm being a bit unfair to you, but I just need you to see where the subject will go with you. There's no big deal. They're addition reactions anyway, is the important thing. They're additions. You're adding it on to the triple bond, and then you're adding it on to the double bond. So you see what's happening is this has been integrated into that, okay? Very important that you can deal with it like that. And lastly there, you're asked to name the compounds. Are you okay with that? I'll write them out for you and see how you're doing. Name those compounds in your list and you should be okay. The first one, now these are very awkward, they always are. I put them down like that, okay? CH3, CH2Cl, triple bond CH. Now folks, I'm deliberately leaving like that. You'll never try to answer that. Always draw the skeleton before you try to name it, if it's anyway awkward. Watch please. CH3, CH2Cl, that's not right. I've taken that down incorrectly, I think, have I? I have CH2C, that's a C. Sorry, CH2, that's a C there. That's a triple bond there. And that should be CH. CH like that, okay? Now, much easier to name now, in every sense of the word. 1, 2, 3, 4. 4 carbons, and it's an alkyne, so it's butyne, okay? And to be precise, it's but-1-ine, because it's at the first carbon. Now, somebody might argue with me, say it's at the third carbon. No, always the smallest number. If you're looking at that molecule, it's the same that way. It's the molecule just turned around. Can you see? So that's number 1, that's number 2, that's number 3, that's number 4, and that will be the name of that. Very good. And the last one there has a Cl in there, I think, hasn't it? It has. Has it 4? It has, yeah. We've replaced that with a Cl. Yes, replace that with a Cl. So you'd have a Cl there. Okay, so it would still be the same parent, except you'd have a chloro there in front of it, CHLORO. Now they're tough. In your defense now, I have to say they're tough. They're only in there to set you thinking a little bit that, like, you know, you need to kind of work on the base of having a method more than anything else, and there won't be any issue. But that's it, and that's what you're after. Good. That's all they'd require of you, and that's fine. Now the last 2 ones there, I'll finish with these. Draw the structural formula of 3,3-dichloropentine. 3,3-dichloropentine. 3,3 dichloro, CHLORO, pentyne, PENTYNE, pentyne. Okay, that's the parent name, okay, that's the family name, that's the first thing you go after. Yne means it's an alkyne, and pent means 5. So here we go. 1, 2, 3, 4, 5. And pentyne means there's a triple bond in it, okay? So that's number 1. Okay, that's number 1. So put in all the pieces next. That's 1 bond. That doesn't need any bond, it's 4 already. This needs 2, this needs 2, and this needs 3. Very good. Okay, now it tells you there are 2 chlorines and they're both at the 3rd carbon. That's number 1. So they're both at the 3rd carbon. There's a chlorine there and a chlorine there, and you're finished. Except don't forget to put in the H's. Okay, a H there, a H there, a H there, there, and there. Now, do you see what the point I'm making to you? It's not about do you know the answer, but do you have a method? That's very important, right? That you draw the skeleton first. Okay, that you put in the various bits and bobs that are there, and that you finally put in the hydrogens. That's what they want. And the other one there is 1,1-dibromo-but-2-ine. Will I do that for you? 1,1-dibromo, BROMO. Okay, dibromo, but-2-ine. So there's the parent again. It's but, so there's 4 carbons. 1, 2, 3, 4. But-2-ine means there's a triple bond after the 2nd carbon. Good. Put in all the bonds next. This needs 3. This needs none. This needs none. And this needs 3. And it tells you that there's 2 bromines at the first. Br there and Br there. Wouldn't matter if you put it there, but 2 of them at the first. That's the answer. Don't forget to put in the H's. And that's the method, and that's what you're dealing with. Now, when we start the next video, I'll be starting with the preparation, the mandatory experiment to prepare ethine. Okay, and then we'll be going into petroleum. We'll be going into the fuels, the section on fuels that's on your syllabus, and that's what we need to do next, and we need to get them done urgently because that will bring our course to a conclusion at that stage. All right, so everybody now please make sure you have the notes with you, the organic notes for any subsequent video. You have 6 pages in all. I've only referred to 3 of them at this stage, and I'll be even backtracking on them as we go through it. All right.